Let's first find the average cost function. This is written as C bar of x, and this is given by the formula the cost function divided by x. So let's put the cost function as given here, which is x cube minus 8x squared plus 20x. We divide this by x. So we divide each of the terms in the numerator by x, and doing so we get x cubed divided by x is x squared, and then the second term is negative 8x squared divided by x is negative 8x, plus the third term is 20x divided by x is 20. And so this represents the average cost function. Now we should find the production level at which the average cost is minimum. So for that we have to set up this equation, that is C bar prime of x equals 0, where this C bar prime of x is the derivative of the average cost function. So let's find the derivative of the average cost function. So I write C bar prime of x, and this equals the derivative of x squared is 2x minus the derivative of 8x is negative 8, and the derivative of 20 is 0. And so 2x minus 8 is the derivative of average cost function. Now let's replace c bar prime of x equals 0. So therefore we get 0 equals 2x minus 8, and we solve for x from this equation. So I write 2x equals 8. Otherwise, solving for x, we get x equals 8 by 2, which is 4. Now, we see that at this production level, the average cost is minimum. We can also verify that by finding the second derivative of the average cost function. So, let's find the second derivative, which is c bar double prime of x. And so this equals, we find the derivative of 2x minus 8, which is 2. And this is greater than 0, irrespective of the value that we substitute over here. So it is independent of x. And whenever the second derivative is positive, we see that it's a point of minimum. Thus, we have verified that at x equal to 4, the average cost is minimum. Therefore, we write at x equals 4, average cost is minimum. In the second part of this question, we show that marginal cost and average cost are equal at this production level. That is, at x equal to 4, the marginal cost and average cost is equal. So let's first find the marginal cost. The marginal cost is given by the derivative of c, that is c prime of x. And so let's find the derivative of the cost function. The derivative of x cubed is 3x squared using the power rule, minus the derivative of negative 8x squared is negative 8 times the derivative of x squared, which is 2x, plus the derivative of 20x is 20 times 1, that is derivative of x. And so simplifying this, we get 3x squared minus 8 times 2 is 16x plus 20. Now we should find the marginal cost at the production level x equal to 4. So let's find the c bar prime of x. That is replace x by 4. This one is the marginal cost at production level x equal to 4. So replacing x by 4, we get 3 times of 4 squared minus 16 times of 4 plus 20. And so this gives 3 times of 4 squared is 16, minus 16 times 4 is 64 plus 20, and this equals 3 times 16 is 48 minus 64 plus 20, And so this gives 48 plus 20 is 68. 68 minus 64 is 4. So this is in dollars. This is the marginal cost at a production level of 4. Now let's find the average cost at a production level of 4. So we are going to use this average cost function, plug in x equal to 4 into the average cost function. So we write average cost at x equals 4, and this is given by c bar of 4, and this equals, we have x squared minus 8x plus 20. Let's put it here, x squared minus 8x plus 20. Replace x by 4, we get 4 squared minus 8 times of 4 plus 20. And so this equals 4 squared is 16 minus 8 times 4 is 32 plus 20. 16 plus 20 is 36. 36 minus 32 is 4. And this one is in dollars. So therefore, we see that the average cost is $4 and the marginal cost is also $4. So we see that average cost or the marginal cost equals $4, and average cost is also $4, and this means these two are equal at production level x equals 4.